The table below contains values of the polynomial function f of x, its first and second derivatives, and the integrals as shown here. We want to evaluate d dx of f of x squared when x is 2. Well, we're going to have to use the chain rule here. That is going to be twice f of x times the differential of the inside function, which is just f dashed x. So that's going to be twice f of 2 times f dashed of 2. And now we're going to refer to the table. F of 2 we can see is 4 just there. So that's going to be 4. And f dashed of 2 we can see is negative 4 just here. So that's going to be negative 4, giving us negative 32. So next we want to evaluate between 2 and 4, the integral of f of x plus 2. Split the integral. It's going to be the integral from 2 to 4 of f of x dx plus the integral from 2 to 4 of 2. This one's going to be f of 4 take away f of 2, where capital F represents the integral of small f, plus 2x from 2 to 4. We can read from the table, f of 4 is 12.8, f of 2 is 10.4. So we've got 12.8, take 10.4, and then this one evaluates in the normal way, so it's just going to be 8 take away 4. And if we put all of that together, we're going to get 6.4. Evaluate the differential of the integral from 2 to x of f of t dt. Well, we know that we want that when x is 2. So we know that this is, by the fundamental theorem, just going to be f of x. So we just want f of 2, and we saw earlier that that was 4. So next we want to determine the x-coordinate of any stationary points and whether they are local maxima, local minima, or points of inflection. So if we look at x equals 1, f dash x is 0 there. It's also 0 here at 4. Now there's a couple of different things that we can do to look at what happens. So the second differential here being negative 9 tells us that the curve is concave down there, and therefore at this point we must have a maximum. Here the differential is 0, which tells us nothing, but we can use a sine table and we can see the gradient goes negative, 0, negative. Negative, 0, negative tells us we have a point of inflection, a horizontal point of inflection. So we've identified at x equals 1 that we have a max, and at x equals 4 we have a horizontal point of inflection, and we know it goes this way because of the negative, 0, negative. So E says sketch a possible graph of f of x for x between 0 and 6. Note that we actually know very few of the values here. We know 2, 4 and 4, 0, and that's all we know. So that's why it means a positive one, a possible one. So 2, 4, and we know there's a maximum there, and 4, 0, we know there's a horizontal point of inflection. So a possible graph is that it comes up, takes a maximum, goes over here, takes a point of inflection there, but we know that it then continues downwards like so. So we need a horizontal point of inflection there, a maximum point there. So something like that would do the trick.